kinetic energy because the rotation of the ball creates the kinetic energy that the ball has. This is an example of the law of conservation of energy because the ball has as much energy going up in the air as it does coming back down. This is an example of work because the ball is moving in a lateral direction while also going against gravity and air resistance. When I pull my leg back to kick the ball, my leg has potential energy, and then my leg transfers that energy into the ball, which makes it move. This is a really hard example to show, but the Magnus effect is a part of soccer, and it's where a person kicks the ball and the ball catches air, and it creates high and low pressure, air pressure pockets, which then creates the ball to curve instead of going in the direct line that it was meant to go in. Since the ball has a specific mass and it has velocity as it's moving up or down, the ball has momentum. Juggling is an example of equilibrium because whenever you juggle, the ball comes down, hits your knee, and then goes back up. So in the split second that the ball comes down and hits my leg, the potential and kinetic energy, the kinetic energy going up equals the amount of gravity pulling the ball down, and so in that moment the ball is in equilibrium. After the ball hits its peak, has gravity is the only force that's acting, one of the only forces that's acting on it, so it gets pulled down. This is an example of friction because we know that an object in motion wants to stay in motion unless acted upon by an outside force. Friction is an outside force that slows the ball down, which then makes it stop. In soccer, the movement of the ball in any direction is a vector because it has a velocity and a cardinal direction of where it goes. This is two examples of object in motion wants to stay in motion because when I kick the ball, it continues to roll until it hits the side of the sidewalk, and once it hits that, it wants to stop and then roll it back and it actually stops moving.